Hi, I'm Oskar Weigl. I'm the CEO of ODrive Robotics. I'm here to talk to you about the ODrive. So, the ODrive is a low-cost, low-voltage servo motor drive. I started working on it when I was doing my master thesis at Imperial College London. I needed a way to drive a brushless motor in position control efficiently. And uh, I basically didn't have the budget to get an off the shelf solution. They were all way too expensive. And I wanted to build some, other cool robots in my spare time, but also, again, everything available was too expensive. So, for example, um, at the Imperial College Robotics Society, we had some of the first RepRap 3D printers, and they were kind of slow and noisy because they used stepper motors. And at the time, I was also working on drones, and these brushless motors that you get on drones, they're really cheap, really inexpensive, and um, I call these like hobby motors because they're really made down to a low price. But they have a lot of power. Like something really small is rated to like 1 kilowatt. It's kind of ridiculous. And at the time, I was also doing a internship at ABB Robotics, working on servo drives. So I kind of knew um, like the control loops and the software needed to make a servo motor controller was actually not that complicated, and and really these motors are so cheap. It would be really cool if we can turn these inexpensive, powerful brushless motors into precise servo motors for all kinds of robots. So, young naive university student, I was like, it can't be that hard, right? And there's some truth to that. Like there, the it is a current controller that and a power stage, and you have some current sensors, and you run your current controller, and then you have encoder feedback, and you run your velocity and position control loops, and on the surface, it's kind of it isn't that hard, but there's always details. So, but anyway, undeterred, I was like, okay, let's make one, and yeah. So these motors, they again, they're really powerful and cheap, and um, they're called ESCs, the electronic speed controllers. The um, drive electronics that you get on for these hobby motors, they're also really cheap, and you can find some pretty high resolution, I mean fairly high resolution encoders for cheap as well. And then tie it all together with some microcontroller and some software, and it shouldn't, that isn't that all you need. So yeah, if you sum up all those parts and look at the supposed power rating, and you compare it to what's available, like especially steppers, they're pretty inefficient, and both like price, performance, and straight up efficiency, and existing servo motor solutions, they were just really expensive. So there's a huge gap here where I was like, I mean, I should totally just try and make this myself. So yeah, that's what I did. I mean, this is it wasn't called ODrive back then, but this is essentially ODrive version 1. This is the what I made for my master's thesis. I took one of these Chinese ESCs. I desoldered the 8-bit microcontroller, and I soldered on some wires for the control signals for the gate drivers, and I hooked them up to a development board, and it worked. See if I have, yeah, it. Yeah, I could do my project. So it was a success. I was able to just add an encoder with this really inexpensive off-the-shelf ESCs, and just add some software, and it works. But actually, a fair amount of my time for my thesis was spent making this motor controller software, and only a little bit was spent doing the research I was supposed to be doing. Oh well. So yeah, after university, I in my free time I built another motor controller. It was this, which also wasn't called ODrive at the time, but backwards applied, it's ODrive version 2. This is based on a Altera FPGA, and it was kind of just like a playground where I had these 9-channel half-H power drives, and 40-pin arbitrary input, and I could play around and make whatever I want. But it kind of, the only thing I did make was 2-channel brushless motor drive, and 1 channel for the brake resistor, and regular encoder input. And that's kind of like, I thought that was great. Like, I didn't really play around too much with making it do all kinds of weird stuff. Like, I just did that. So I decided, you know what, we don't need an FPGA here. I just kind of condensed it down to a microcontroller, and the two, it's kind of what I had in ODrive 2. 2 motor channels, a brake resistor, and that was it. And here you can see it go. So I kind of posted online about this, and was showing on a Hackaday.io blog, and showing other people what I was doing, and taking these hobby motors and making them do precise control for robotics with coder feedback. And I got a lot of attention. People really wanted to do this. People wanted to make either more powerful and efficient robots if they were using steppers, or cheaper robots if they're using industrial servo motors, and ODrive could do that. It was just a basic kit at first. I helped source some hardware, and it kind of took off. It started off with just a few hobbyists who also wanted to play around, and then more and more kind of people decided they were going to use it for their robots, and now there's just so many different people use it for so many different things. I want to just highlight a few. So one of my favorites is the Stanford Doggo. This was made by the Stanford student robotics team, or robotics society, I think. And it's a quadruped robot with some coaxial linkages here. Yeah, if you haven't seen it, you should check it out. Then we have we put up a forum where people can post about what kind of stuff to build with ODrive, and a community started to form around this, where people were sharing what they were doing. They were talking through problems they had with each other. And I mean, I get to, I started ODrive I made ODrive because I wanted to build some cool robots myself, but now I get to see all these people building some really cool stuff, and it was very motivating to see that I've been able to help others build some really cool stuff. Like here's, for example, this Stewart platform or a quasi direct drive actuator. But these are just a few examples. There's so many different things. Oh yeah, here's it took a while. I first started posting about the original kind of ODrive version 3 back in like 2017, and just this year was the first real kind of serious high-speed 3D printer. And as you saw in the beginning, one of the first things I wanted to use ODrive for was with 3D printing. But yeah, it's if you want to check that out, that's Vez 3D. Yeah, their printer's pretty cool. And yeah, back in like it started with hobbyists and enthusiasts who wanted to join in with me and build cool robots in a way they couldn't afford to before. But as the product matured, the software had more features and got more stable. More and more companies wanted to build serious products with ODrive. They wanted to integrate it into their robots to do delivery or agricultural robots, manufacturing. You see this large 3D printer, cable cameras, exercise machines, lawnmowers, all kind of commercial OEM serious robotics applications. And so we've come a long way from like the student who built me as a student who built this inexpensive drive to now supplying lawnmower robots. And I am so blown away by all the different cool things I get to see people build, like wave generator for ocean research labs or telescope tracker. So just all these things I would never have dreamed of building myself. With this, I get to kind of experience vicariously, see all these people build this cool stuff, and it's yeah, I'm so happy to be able to empower all these people to build so many cool things. So I want to talk a little bit about the design philosophy of ODrive. So we had before the comparison with all the existing off-the-shelf motor controllers and motor drives, and really the way that that ODrive is able to be so attractive is the low cost and the flexibility that you have. So to get the cost down, it really is all about getting rid of all the fluff and just focusing on the basics. And like just doing exactly what's needed to drive motors at high performance and nothing else. Just the core. And that's what we have with the ODrive 3. We have like the power source, the electrolytic capacitors, a pair of inverters, the brake resistor, and the rest is software. Like really, ODrive is like you can see here, it's just the microcontroller, the gate drive, the power FETs, the DC bus capacitors, and like maybe a CAN transceiver. That's about it. Like there's almost no other parts on here. And still, like ODrive does enable some stuff that you kind of it was a lot of like there's a lot of stuff put into ODrive still for like many years we worked on this, and it really comes down to the software. Like ODrive is a very software defined solution, you could say. And yeah, it's all about enabling people to build cool robots. And So already from the start, we had features to reduce integration time. Like we had resistance and inductance measurement, automatic calculation of the current controller's PI gains, automatic registration between the rotor angle and the encoder angle. We developed this library called Fiber, which is a self-describing communication protocol. So when you have this like declaration of your C++ classes all the way down in the heart of the firmware, you have the inner controller of the current controller. You can just point to one of the variables and say, I want to make this available to read and write. And we have this infrastructure to make it really easy to just point at this variable, and it gets declared into a schema, and that then gets display when you do a connection between the ODrive and like the host. This schema gets negotiated, and it tells the host, hey, we have this variable that was declared. It's here in the object tree, and it makes it really easy to for both us and people using ODrive to add new functionality, and it kind of just automatically integrates and just works, and it shows up, in the other parts of what the ODrive connects to, and yeah, and again, like we have ODrive's open source, and the reason like we decided to make it open source is, I built this to be the motor controller I would want to use if I built a cool robot, and for that, like the ultimate thing for that is I can just go in and add stuff to the source to do what I want. And so that's why we've stayed open source, is to enable like really deep customization, and you can very quickly add some little tweak to the controller, so it'll tweak to like some state machine, and it kind of lets you do that. Over time, we started with, you go at it yourself what you need, and over time it's been like we've kind of identified a lot of commonality of what people want to do, and we write those features in, and then we make it, we add a bunch of configuration parameters. So how should I say, it started with like, you go do it yourself, it's fully customizable, and now it's like, oh, actually the feature is already there, you just need to configure it. So that's cool. And we're working on a graphical user interface. Should be ready hopefully this year, at least the beta, and that will even further help people easily build what they need. So I want to talk a bit more about open source. So like I said earlier, the main reason we have kept ODrive open source is to enable people to really change things up the way they want to, and make ODrive, it's very enabling for people to use ODrive in their application. And ODrive has seen a lot of success in terms of the open source. People take the ODrive codebase and they modify it to what they need. They take the ODrive hardware design, they change it up, they change the form factor, and it's we know it's been integrated in lots of different research labs and custom kind of form factors, and even in some products. So one of the things we were hoping to do when we made it open source to start with was to kind of have this community where people building cool robots, they added things that they need, and then they push it upstream so other people can use that too. But it didn't really go like that. Um, we got many people, finding issues, but then they would tell us, "Hey, we found this issue," and then very few pull requests and contributions back. And I think it's probably two reasons why we don't see people engaging with the project and helping out. It's um, for one, it's highly technical um, to add something in the controller down on an embedded platform in the microcontroller, writing C and C++. All of this is kind of, not everyone can do it, but a lot of people want to build robots that don't have this skill set. So I think the ratio of people who go down and really customize stuff to the people who just use ODrive to build a robot is actually not. It used to be much more, and now that we built out more ease of use tooling and have more features already, people just use the ODrive and they don't want to touch the code. Uh, but also people who are kind of skilled enough to go in and change things, um, they have a project to get done. They have a research project to finish. They have a product to ship. They have um, they have other things to do, and they don't really have want to spend the time in contributing back. They just want to use the ODrive, do what they need to do, and that's it. And I think even some commercial um, products who add their own stuff on the ODrive, for them it's even a negative incentive. Like they really don't want to share back the stuff they added because that's their competitive advantage. So I think for a lot of reasons, we really, we really don't see much engagement um, on the open source. I would say, um, I would say like the open source is a huge success in that people can customize what they need, and that's really been a huge, like, people tell us that this is really great and they love it. But it's been also less of a success when it comes to this kind of engagement and contributions back. Um, yeah. Um, yeah, so going forward, what we want to do with ODrive is, it's been, it started as a hobby project. It was just, and then we built out this kind of uh, minimum viable product, you could say, almost like which was the ODrive 3. It's, it has just the minimum of what you need to do um, high power, precise position control and trajectory control, and velocity control, all those precise control of brushless motors and nothing else. Um, but with um, more maturity in the software, um, it can kind of opens the door to more serious kind of applications, more harsher environments. People demand things kind of just work, and so we, um, going forward, we're working on making the software more robust and making the hardware more reliable, and just making everything easier to use. So with that, going forward, what um, our plan is to, we're working on ODrive version 4. It's takes everything we learned from ODrive 3 and adds a lot of, like, robustness, um, better error handling, and more deterministic kind of state machines, and but also like protections and voltage clamping and isolation, CAN FD, higher communication rates, and not to mention like locking connectors and just a more ready to go form factor. So yeah, we're very excited about ODrive 4, and we keep working on this, making like what we're really trying to do is make building robots easier, and remove the foot guns, make it harder to mess up and easier to succeed. And I'm just really excited to see all the cool stuff people build with it, and I would love, if you guys make something cool with ODrive, I would love to see it. Yeah, thank you so much for your time, and I think the question and answer session is going to be live separately, so looking forward to that, and thank you for having me.